So I'm going to give you a rule that's going to be able to be, you can kind of apply that to all scenarios of that exponent. And then we're going to do an example and an expanded version so we know what is it really asking me to do. So the first rule that I'm going to give you is b to the m times b to the n power. So, for example, if I had x to the third times x to the fourth power. So I have two exponents. They both have the same base. They're both x's. X to the third times x to the fourth. Now, what does that really mean? What is x to the third power? What is that asking me to do? X times x times x. 3 times. It's telling you how many times to multiply it times itself, right? Times, because really they're just multiplied together, and then x to the fourth is an additional x times x times x times x. So really this is just all multiplying. Ultimately, how many x's are there that I need to multiply together? 7. So my answer would be x to the 7th for this problem. So what's kind of like the shortcut or the rule that we can apply to exponents? If I'm multiplying the same base, how do we get from 3 and 4 to 7? Yeah, you're really just adding together all of the number of times that you're multiplying x. So the rule is to take b and then you add the exponents m plus n. That's kind of like the root rule, the base rule of all exponents. That's probably the one that occurs most often. Okay. The next one, I have b to the m to the n. So it's an exponent raised to another exponent. So the example that I'm going to give you is x to the second to the third. Now ignore what's inside the parentheses. What is anything to the third power? What is that asking me to do? Cube it, right? Whatever's in there, it could be, I don't know, an elephant. We have to multiply that times itself 3 times. So this is actually x squared times x squared times x squared. That's what x squared cubed means to do. And now we're kind of back to step 1, because what is x squared? Just x times x times x times x times x times x. So how many x's are there? 6. So our answer would be x to the 6th power. So what's kind of the shortcut that we can use? What did we do to 2 and 3 to get to 6? We didn't add them together. We multiplied them. So the rule that we'll follow is we'll take the base and raise it to the m times n power. It's kind of saying we need 3 sets of 2, which means to multiply. 3 sets of x squared would be x times x times x times x times x times x. Okay, number 3, a b to the m power. So this is the first time we have 2 different things in the parentheses, and they're different bases. That's represented by the a and the b. And the example that I'm going to give you is xy squared cubed. So xy squared is in parentheses, and that whole thing is being cubed. Now, once again, kind of back to step 2, what does it mean for anything to be cubed? Multiplied by itself 3 times. So what that means to do is to do xy squared times xy squared times xy squared. Do what? Now, y squared, once again, kind of goes back to step 1. Xy squared is y squared, or y times y. So x times y times y times x times y times y times x times y times y. So what would our answer be? How many, now the order of multiplication doesn't matter, so what's x times x times x? X cubed And then y is y to the 6th. So what happens when there's two things inside the parentheses and they're both raised to an exponent? What happened to x and y? Yeah, they both have to get raised to that exponent. So you can see it ended up being x cubed. And then the y squared cubed kind of goes back to step 2. I had an exponent to an exponent, so we multiplied them. But regardless, a has to be raised to the m power, and b also has to be raised to the m power. So you can kind of think of doing them separately, both to the m power. Okay, the next one, we have a base to a power over the same base to a power. B to the m over b to the n. And the example I'm going to give you is x to the 7th over x to the 4th. Now the numerator is just step 1. X to the 7th is x times 7 times. Over, and then x to the 4th is x times x times x times x. What is 5 divided by 5? 1. What's 10 divided by 10? 1. What's 20 divided by 20? 1. What's 4 million divided by 4 million? 1. What's x divided by x? 1. X divided by x is 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 1. They all cancel out to 1, except how many? 3. So what did we do to the exponents? Yeah, you're basically subtracting the ones that cancel, right? And that's how many are left. So our rule is we're going to take b, and then we're going to subtract m minus n. Makes sense, because those are the ones that are canceling. So we subtract those, and that's how many exponents are left. Okay, number 5 is a lot like number 3. It's just the fraction form. So if I have a over b to the m power, if you had to take a wild guess, what do you think is going to happen with a and b? Do what? They're both going to get raised to the m power. Good. So if I have x over y to the 3rd power, we kind of go back to the previous ones. Anything to the 3rd power is whatever's in there multiplied 3 times. So what this is x over y times x over y times x over y. If you go back to elementary school, the way we multiply fractions is straight across the top and straight across the bottom. So on the top, we have x times x times x, which is x cubed. And on the bottom, we have y times y times y, bless you, that's y cubed. So you can see, ultimately, they both get raised to that power. So our rule that will follow, a to the m power over b to the m power. And number 6 is really easy. Some base to the 0th power. Do you remember this one? Put it in your calculator if you're not sure. Do 5 to the 0 power, 10 to the 0 power, negative 3 to the 0 power. What'd you get? It's 1. So, what is that? 1. The whole thing is raised to the 0th power, so the answer is 1. You don't have to write that down if you want to. You can. And then the last one, rule number 7, is that pesky negative exponent. So b to the negative n power. B to the negative n power. Now let's take a look at our calculator here, and let's see a few of these scenarios. So if I have the number 2, and I raise it to the negative first power, so a negative exponent, 2 to the negative first power, and I hit enter, and I'm going to turn that into a fraction. What is it? 1/2. Let's do 3 to the negative first power. It's 1/3. 6 to the negative first power is 1/6. So does a negative exponent mean that the number is negative? No, that's a common misconception. A negative exponent, what is it doing to that number? Not cutting it in half necessarily, because half of 6 isn't 1/6. It's putting it under 1. So what happens is it goes 1 over and then b to whatever that exponent was. There's no negatives involved. The number is not negative. It's just telling you that it's the reciprocal of that fraction. It's upside down. So, for example, if I had x to the negative 7th power, you're just going to write 1 over x to the positive 7th power. All it does is move it to the bottom of the fraction and make it positive. Bless you. Now that also happens, I'm going to write it over here, but that also happens backwards. So let's say if we have 1 over x to the negative 4th. What do you think is going to happen if it starts on the bottom with a negative exponent? It's going to come up to the top, exactly. So that would actually just be x to the 4th. Over 1. You don't need to write over 1, obviously. So if it's on the bottom of the fraction, it's just going to come to the top of the fraction and become positive. All right. Everyone good with those? We're going to do 2 examples today. So I know, go ahead and flip to the back. There's over on the right side of the back side, there's kind of some blank space. You see that? You can just do the 2 examples that we're going to do over there. So the first one, on the board, we have 2x to the negative 2nd power, y to the 4th, all raised to the 2nd power. So now we're going to start grouping all of these exponents together. You pre-calc and calcers, this is really good practice. Very commonly missed in calculus is rules of exponents. So let's do this one together. How many things are in the parentheses? There's 3 things. There's a number. There's the number 2. There's the x variable and the y variable. All 3 of those things have to be raised to the 2nd power. So we're going to start off with 2 to the 2nd power. What is 2 to the 2nd power? Proud of you. Don't forget the number. Like if there was a 3 in front, what's 3 to the 2nd power? 9. Right? So you have to take the number to the power as well. Now the one in the middle is an exponent raised to another exponent because that negative 2 has to be raised to the 2nd power. So that was actually step 2 on the front, if you don't remember. But what happens when you take a power and you raise it to another power? You multiply them. So what's negative 2 times 2? Negative 4. Good. And we'll worry about that later, but just write negative 4 for now. Try not to skip too many steps. That's where you get in trouble. And then the last one's going to be y to the what? Y to the 8th. Now, your answer can never have negative exponents in it. That is not a simplified answer. On the ACT, and you guys are all juniors and seniors, they would never have a multiple choice answer with negative exponents. So ultimately, where does this x need to go? To the bottom of the fraction. Now the 4 is fine. The 4 is its own thing. That's like 4 to the 1st power. The 4 is going to stay up top. The y is going to stay up top. But the x term has to go down to the bottom and become positive. Once you have 1x, 1y, no negative exponents, That's your final answer. So that there would be it. All right, last one for today. Go ahead and do example number 2 on your own. Give that a try. So if you're struggling a little bit, that first step I would do in red right there. So 3x, don't do anything with 3x yet. But x squared has to be raised to the negative second power, so we multiply. And then y has to be raised to the negative second power. And that whole thing is still being raised to the third power. So that's what I mean by working inside out. So do the small parentheses first. Now I would still focus on inside out. So I wouldn't worry about this 3 just yet. Just focus on anything that you can maybe simplify on the inside right now. Okay, there's the next step. Where did I get this negative 3 from? Yeah, when we multiply these two x's, that's x times x. What do we do to our exponents when we multiply same base? That was step 1 on the very front. You add them together. So whatever the exponents are, now technically this is x to what power? X to the first power, right? So if we're going to add those exponents together, 1 plus negative 4, aka 1 minus 4, is negative 3, right? Okay, so now, I'm going to pull this down a little so I have some room. Now, everything on the inside is simplified for the most part. I don't deal with negatives until the very end. Why do you think that is? Do what? Yeah, well, what if this exponent's negative? What's going to happen with these when I multiply negative times a negative? Yeah, so sometimes it becomes positive on its own. It'll work its way out. So I always wait till the very, very end to deal with any negatives. So for now, let's go ahead and do 3 cubed. Now be careful, that's not 3 times 3. That's 3 to the third power. What's 3 times 3 times 3? 27, good. Common mistake, people do 3 times 3. That's not an exponent, it's 3 raised to the third power. Now we have a power to another power. So what am I going to do to those exponents? Multiply, that becomes x to the negative 9th and y to the negative 6th. And now the 27 is going to stay where it's at. That's 27 to the first power. There's no negative exponent happening there. So our final answer is going to be 27 over the x and the y both have to go to the bottom. And that would be it. So 27 over x to the 9th, y to the 6th.